Okay, so this is section 6.2 for pre-calculus. In 6.1, we talked about drawing angles. We always talked about degrees. It might have been a positive degree or it might have been a negative degree. Well, there's actually two different ways to measure angles. Not just degrees like we did in the last section. So degrees is one way. And I'm going to put here, that's what we did in 6.1. But another way to measure angles is to use radians. Okay, to use radians. All right, that N doesn't really look like an N, does it? Radians. And don't be confused by this. It's kind of like to measure the temperature outside. You have Fahrenheit, but if you were in Europe, say, you would use Celsius. So it's just two different forms of measurement, and we use both. The thing to keep in mind is that our conversion formula, in order to switch from degrees to radians or radians to degrees, conversion formula is to know that pi, and I know you learned back in geometry that pi equals 3.14, but I don't know if your teacher talked about it's 3.14 radians. So what does pi equal in degrees? Well, pi equals 180 degrees. So if I want to change from radians to degrees, so look at number one, I might say, hey, you have an angle that measures pi over 3. Well, that only has meaning to me if I can think about how much of a rotation that is. Well, if I want to change from radians to degrees, that means I want to get rid of the pi. Well, if I want to get rid of the pi, I'm going to replace it with 180. So basically, I'm going to substitute, right? I'm going to substitute 180 in for pi. So I've got 180 in place of pi divided by 3, which is going to equal 60 degrees. So pi over 3 is the same as 60 degrees. Now, here's something you're not going to like. And the first couple days, it's going to be a little bit of a I don't know if tedious is the word, but you're going to have to force yourself to do this. But trust me, you need to get in the habit of looking at these numbers without using a calculator. Because number one, you're not going to be able to use a calculator on a test or quiz or whatever. But as we go through, you don't want to have to do the math, the computational math with a calculator, because these are never going away. And you're going to notice that the same numbers are going to come up over and over. And if you do the same thing over and over, it's going to be so much easier to kind of look at it and very quickly make the switch. You have to trust me. No calculator at the beginning. Get used to these numbers. It's going to be the same numbers, and you're going to get so much faster and be so much more competent with working with these numbers this semester. Okay, so let's skip number 3 for just a second. Let's go down to number 2. If I want to change this into degrees, so like we said, you're going to replace the pi with a 180. And so here's what I have. So if I were using a calculator, I might say, okay, what is 5 times 180 and then divide by 6? But you don't need to go through all that work. Think about the numbers. I can just cancel out, right? I can say, hey, 6 goes into 180, and you might be saying, what, 6 into 180? But think about 6 and 18. If 6 goes into 18 3 times, then 6 goes into 180 30 times. And so what I actually have, since those crossed out, is 5 times 30, which is 150. Now, again, I know that took us a minute to talk through it, but the more you do this, you're going to simplify these things so quickly and easily. Okay, so let's look at number 4. Let's think the same thing. So I'm going to have 3 times 180, and I'm dividing by 2. So do a quick simplify. 2 into 180 is 90. So 3 times 90, 3 times 9 is 27. So 270. Okay, now I saved number 3 for last because it's not as intuitive, but you need to kind of get this in your head. Again, it's going to help you a whole lot later on. So when I first substitute, I'm going to have 180 divided by 4. And I get that 4 into 18 doesn't go nice and neat, but let's do a little bit of a little bit at a time. What about 2? right? 2 goes into both 18 and into 4. So 2 into 180, 2 into 18 is 9. So 2 into 180 is 90. And 2 into 4 is 2. But can't that go one step further, right? 2 into 90, so divide 90 by 2, and that's going to be 45. Now, I know that took a little bit longer, but get that in your brain. Burn that in your brain. If pi over 4 comes out to be 45, then what that really means is, and this is what we want to hope to use to go forward, if I have 180 over 4, that 180 divides by 4 evenly to be 45. Again, I know it's not as intuitive, but get it in your brain and don't ever forget it. Get it in your brain. It's going to make your life so much easier this entire semester. Okay. What if I want to switch the other direction? So what if I want to go from degrees to radians? In other words, I want to get pi in there. So somehow I have to put a pi on this. So what I'm going to do is I'm going to multiply by pi over 180. Now think about it. Since pi equals 180, then pi over 180 is kind of like 180 over 180, which is 1. So really you're only multiplying by 1, which means you're not changing the value, which is good, because we don't want to change the value. We just want to change the form. We want it to be in terms of pi, not in terms of degrees. Okay, so for 30 degrees, if I multiply by pi over 180, all right, don't touch the pi because I don't want to get rid of pi, but now let's do like we did before. Let's simplify 30 and 180. Well, first of all, the zeros can cancel. 3 goes into 18 6 times, so really all I have is pi left on top, and on the bottom 6. So 30 degrees is the same as pi over 6. Okay, let's go with 210. So I'm going to multiply by pi over 180. Okay, again, the zeros cancel. 21 and 18. Always think about 3s and 6s. Those are going to be the numbers that come up all the time. Doesn't 3 go into both 21 and 18? So 3 goes into 21, 7. 3 goes into 18, 6. So what I actually have here is 7 pi over 6. Okay, 3s and 6s, they come up all the time. All the time. All right, so what about 120? Well, if I want to change it to radians, I'm going to multiply by pi over 180. Okay, the zeros cancel. In this case, I could go 3, but what about 6? Doesn't 6 go into both 12 and 18? So 6 goes into 12 2 times. 6 goes into 18 3 times. So this is going to simplify to be 2 pi over 3. Okay, number 4. I'm going to change this to radians, which means I want to get the pi in there. So if I multiply by pi over 180, you could think, well, 180 is half of 360, or maybe you don't think in big numbers like that. Cancel the zeros. Can you recognize that 18 is half of 36? So basically, they cancel and it just leaves a 2 on top. So this is just going to be 2 pi, which hopefully that makes sense, because if pi is 180, wouldn't 2 pi's be 360? Okay, so that is section 6.2.